Scientists discover what there is, but engineers create that which never was. And in my mind, engineers are creators. We're almost like artists, but instead of working with art, we're working with scientific things or mechanical things or electrical things to try and create something. And that's what's so rewarding about working at Goddard, is that we get these fantastic problems to solve, and we have to come up with really creative solutions to basically create something, in this case a satellite, that will do a certain job and do it well.
For SDO, the majority of the spacecraft was built here in-house. Both the instrument module and the spacecraft bus were built here at Goddard. The instruments were made out of house, but then they're brought here to Goddard and integrated into the satellite.
You know, building up to some of our full systems tests, it's 5 years worth of work all coming together in one final test, and to be able to see it function the way you intended is very, very exciting, and that's a very high point in our careers in building these spacecraft.
This mission, we have a requirement to work on over for 5 years, and we want it to work for 10 or 11 years. So we really have to know that it's not only going to work just now, that we want it to work for a long, long time.
We assembled the entire propulsion subsystem here for SDO. And in addition to that, all of the instruments and all of the electronics boxes were assembled onto the spacecraft structure, and the entire observatory was put together. So really at Goddard we see the culmination of all kinds of work that's done really all around the world. And we all bring it together here and test it end to end to make sure the entire system works.
Well, I started just interfacing with the instruments because I've worked on more instruments here at Goddard than I have spacecraft. And so I was brought in to interface with the 3 outside instruments that were built outside of Goddard with our spacecraft team here. And that was my job primarily, and then I helped integrate them, and then I got moved into helping integrate the entire spacecraft and making sure that everything was good to go.
In engineering, I think if you have a strong tendency towards science and mathematics, it's a very good position to be in. I mean, really, engineering is basically applied physics. You're taking a lot of physics principles and applying them to real-life reality. Enjoying hands-on activities, building things yourself with your hands is a very good lead-in to becoming an engineer. That's how I started, working with cars and things. But if you have a real strong desire to do those kinds of things and you apply some science and mathematics, then you can go ahead and design and build and test your own things, which is what we do here.
I would just really like to encourage the next generation. I think that's something that NASA does in a way that only NASA can do, just to inspire the younger generation to be interested in math and science and outer space and what's out there, and just to inspire them.
Goddard's one of those places where you don't only see the small part of the spacecraft building and the engineering. You have the scientists here too who have the big vision and kind of are able to think about, if I could just do this, then I might be able to prove this, or I might be able to learn this. That's what makes being at NASA exciting for me.